Okay, so let's get started. And I'd like to, first of all, welcome all of you to come to our annual Vatican Observatory Foundation Seminar on Astronomy. The idea is to be able to share with some of our friends the astronomy that we do and the astronomy that some of our friends are doing. Really, it's to show off that we have fun friends that we can show off. I hope you all saw the table out front with goodies like this, which include a web address for our Faith and Science Library. If any of you are, as we say, for Catholic educators, educated Catholics, anybody else interested in the relationship between faith and science, we've got hundreds of resources online that you can download and use in classrooms or just read on your own. We also have a link to something we call the Catholic Astronomer. You don't have to be Catholic to read the Catholic Astronomer. You actually don't even have to be Catholic to write for the Catholic Astronomer.
Do you have to be an astronomer?
You do have, well, you have to have some kind of astronomy. We have a woman who does some articles based on the research she does at the University of Arizona. She's on the faculty there at Stewart Observatory. And she spent a lot of time working in Ireland, so I assumed she was Irish. She goes, no, I'm not Catholic, I just like what you guys do. But it's a lot of fun if you enjoy the conversation that we have today. That's a place where the conversation can continue. The foundation, of which I'm the president, Brother Guy Consolmagno, the foundation is set up to support the outreach work and the astronomical work that the Vatican Observatory does, especially in the U.S., but not only in the U.S. One of the things we support is a biennial summer school where we have 25 students from around the world come to Rome for 4 weeks. And while they're there, they get instructions from some of the great astronomers around the world to let them know about some particular narrow topic of astronomy. The school this coming June, registration is still open until the end of the month if you know any students who might be interested. And the topic is stellar variability. I know it had to do with stars. Stars I don't know about, I'm a planet type. But we have people who do know stars. To show off the kind of people, our very first summer school was in 1986. And one of the instructors for that was Vera Rubin, the woman who discovered dark matter, and who should have won the Nobel Prize. That's a story. The other thing we do, I am, of course, is the director of the Vatican Observatory. And as such, I remind you that we exist, as Pope Leo XIII said in 1891, so that the world can see how wonderful astronomy is and that religion supports it. Literally in the case of the Vatican, because our telescopes are on top of the papal palace, so it's physically supported. The schedule we've got for today, our first speaker is Dan Davis, second will be Richard D'Souza, and third, Audra Basileas. I get the accent wrong. We'll have a break, and then David Levy. So we've got Father Richard and David Levy. We've got a priest and a Levite. So, you know, we've got all And I'd like to first begin by asking Dan to come up here. And as an introduction, I'm going to ask you a few simple questions about who you are and where you're coming from.
Okay.
So come on over here. Actually, you've got the microphone there, so it's being recorded. First of all, you're from Yonkers, New York, right?
Yeah, the city of gracious living, it's called. Yeah, if you've ever been there, you'll know what a misnomer that is. Yeah, if you'd ever been there, you'd know that the title City of Gracious Living is a misnomer, but yes, that's where I'm from.
And you wound up going to high school with Archie and Veronica, Riverdale High.
Yeah, I know. I get, yeah.
It was Riverdale High in the Bronx. You started an astronomy club there?
Yes, I had an astronomy club that I ran, and we got free reign of the school and its telescopes at all odd hours.
Did you have any other interesting members from outside the school show up?
Yes, I had a friend who one day said to me, "Hey, I got this friend Neil who goes to Bronx Sci.
Bronx Science High School.
Bronx Science High School. Do you think maybe he could come to some of your meetings and observe the Pleiades night, observe the Perseids night, just general stargazing, and this really nice kid, a couple years younger than me, Neil Tyson, came along. And
So you've taught Neil Tyson all the astronomy he knows.
right, yeah. And when he was, I tried to lure him. I went to Princeton, tried to lure him to come there. While he was looking at college, he stayed with me, but unfortunately
He chose Harvard.
he chose Harvard. But you know,
So you were
other than that, he's a smart guy.
right. So you were at Princeton. How did you wind up not as an astronomer?
Well, I started out as an astronomer and astronomy major, and I came to realize that I liked things that were tangible. I loved the physics, but I wanted to be able to go out and actually touch the thing I was studying. Plus, I love stargazing so much, I was afraid of turning it into my work. So I went to my advisor, great planetary scientist by the name of Bob Danielson, and he said, oh, there's some geophysicists over the way. You should go talk to them. So basically, I came down to earth.
Okay, excellent. And that's pretty much what you're going to talk about today.
Yeah,
All
exactly.
right. You may know Dan as the co-author of Turn Left at Orion, and I know some of you have copies of that. You may also, I should introduce John Ridley, who is on the cover of the most recent edition, who's helping us out with the videoing. And I'd also, before we get started, like to say a few words of thanks to some of the other people who've made this possible. First, Charlie Nielsen, who's helped out so much, telling people about this through the Lowbrow Astronomers, and Ann Benninghoff, who's been a great supporter of us over the years, and it's a delight to have you here today. Of course, we've got also members of the Vatican Observatory Board. You can see us with these little badges. But Dan, it's up to you.
All right. So I met John earlier. I apologize for not recognizing him, but I said I only recognize him in silhouette, where he is on the cover of the book. So I'm going to talk to you today. Can you hear me? Is this mic on? Okay. The
mic is only for the recording.
Okay, fine then. So I will stay. But can you hear me anyway?
Yeah.
Okay. So, yes, I'm a geoscientist, but I'm also a stargazer. To me, pictures like this from Mars are really exciting. It may look like a bunch of lines to you, but it tells a story. These layers were laid down horizontally, and some tectonic event tilted them. They were then eroded away, and new layers put on top. So this is, this is a story, a tectonic story that you can see, and I'm kind of interested in where else can you see tectonics besides the Earth? Well, might have titled my talk, Why Did a Geologist Become a Stargazer? Or perhaps, how does a stargazer get started studying tectonics? Well, this was some time ago. Hair was a different color. Anyway, I first met Guy when I was a grad student, working with a scientist named Sean Solomon, who later went on to become the chief scientist on the Mercury messenger mission. And at the time, Guy was a postdoc working with Sean. And so we got to know each other really well. I was newly married. My wife and I suffered through a series of signs from the Holy Spirit. No, sorry, girlfriends of guys that God put Guy through all of that as a clear indication of his intended vocation, was our interpretation. But anyway, we went on and did our separate things. Here's Guy in the Peace Corps, me at Stony Brook, where I've been ever since, after doing a postdoc. And we each have done laboratory work, but also some field work. This is me in a place I'm never going to go to again. It's Western Pakistan, right by the Afghan border, but looking at tectonics. Here's a big fold. The story of that fold tells us a lot about the history of that particular mountain belt. Also looking at plate motions, where you can actually use a type of GPS, not the kind in your car that tells you to turn left onto railroad tracks, but rather the kind where if you integrate the data, you can get your location to a centimeter or better and actually track plate motions. So it takes me from interesting places like that to wilds of Western Pacific. Guy, meanwhile, winds up collecting meteorites in Antarctica. I think I got the better of the field sites. Well, maybe, who knows? Some might disagree.
Here that sky is.
Yes, it is blue.
But it never gets dark.
But it never gets dark. Except for the part of year you don't want to be there. So, a friend of mine is a gifted writer and a really good scientist, allegedly an astronomer. He is an astronomer, but I would go out in the night sky with him, and typical astronomer, most astronomers don't really know their way around the night sky. That's not what you do. You go into a room and you plug it in. He knew all of the science. He's kind of like a geologist is. It's really embarrassing for me. People give me a rock and think I can identify it. I know plenty of amateur geologists who are much better at rock and mineral identification than I could ever be. So he has this idea. Why don't we write a book? It was a really naive idea because two people don't go to a publisher without without anything and say, oh, I want to write a book. So I knew I was safe. Besides, I was a new faculty member. The last thing I needed was a big distraction from the pre-tenure process. So I knew I was okay until horrors. One day a letter came from Cambridge Press. And I thought, oh no, we have to do this thing. And it turned out to be an absolute blast. It was just a work of love. It was just so much fun to do. The book came out and nobody noticed. Because Cambridge Press, at the time, they've really improved, but at the time they were oh so British and did not want to get their fingers dirty with things like advertising. So the sales were pathetic for a number of years until finally some people in some astronomy clubs had it and showed it to others. And it picked up enough that we eventually got them to agree to do a second edition, slightly modified, and a third one. And then finally I came to have the opportunity to have a sabbatical where I could actually go away. Up to that point, I had kids in the house. I didn't want to leave them. I didn't want to take them anywhere. So I spent a fair amount of time at the Vatican Observatory in Italy. And we worked on a much revised fourth edition. An awful lot of fun. It's bigger, spiral bound, and takes into account the Dobsonian revolution, the availability inexpensively of good aperture telescopes for beginners. You may recognize, there he is, there he is. So if you just worn all black and bent over, I would have known who you were. The idea of this whole thing is that it's meant to show what you actually see, not photographs from the Hubble Space Telescope that give you no sense of the actual experience at the eyepiece. We came to the point then of saying, okay, let's expand this. So instead of just 4 seasons, we have 6. The 4 seasons, the northern objects, things you can see from the northern hemisphere all the time, and the southern objects, those you can only see from down south. And darn, that meant having to go to Australia. You may remember, back about 7 years ago, there was this period when Australia went through incredible floods. Constant rains in Australia. That's when we went. And you can tell this is our setup here. Very nice looking. Guy's little telescope that's traveled the world. A Dob that we tried to buy, but the vendor refused to sell it. He said, I will donate it as long as you allow me to put a plaque on it honoring my favorite high school teacher, a Jesuit. So we said, sure, that's great. But if you look in the background, you see all the wetness. So, yeah.
You can also see the vineyard.
Yes. However, exactly. It was this was a Jesuit retreat house that is also a vineyard. That has a couple of nice aspects to it. One is it's really fun to watch kangaroos hopping between vines. I have never seen that yet in Sonoma. The other is when the sky is like that at night, there are compensations. And there were ways to drown one's sorrows. Eventually, though, we did get decent skies. And it is incredible. I don't know how many of you have had the pleasure of being in the Southern Hemisphere, but they got so much the better end of the deal in the sky. It is beyond belief. Omega Centauri is a globular that makes M13 look sad and pale, and M13 is spectacular. You can resolve M13 in your finder scope or binoculars. You resolve it into Omega Centauri. You can resolve Omega Centauri in your finder scope or binoculars. This is the best I could do in drawing it, and it doesn't do it justice. Eta Carini and the Keyhole Nebula. It's just surreal. Can you imagine this as an eyepiece field within the Large Magellanic Cloud surrounding the Tarantula Nebula? All of these objects within one field, and if you skew yourself off to the side a little bit, it goes on and on and on. They got an incredible deal. If you ever get a chance, if you're a stargazer, to go down under, it is just awesome experience. So one of the other things we did with the 4th edition was we had web resources. I told you how the first edition of Turn Left at Orion was a well-kept secret, basically, almost nobody noticed it. Well, the same was true of the web resources. We mention it about 2 places in the book, and for ages, almost nobody ever went to them. The reason for it is that maybe you're using a Dob, but you're doing it in the Southern Hemisphere. So everything is upside down. Or perhaps you're using a bigger telescope, but it's a refractor or catadoptric, in which case it's flipped. There are many combinations and permutations for finder scopes and telescope views. So the idea is you choose whatever season you're in, you choose a particular object, and you decide which of the various permutations. Are you in the Southern Hemisphere, so you need an upside down naked eye view, alternative finder scope views or telescope views, and then you can go grab the one you want and print it out. Okay. Also, a whole bunch of additional links. Well, we're going to be following up on this theme with a 5th edition that's, it was originally due this month to Cambridge. That's not going to happen. There is an Italian translation. And so with a name like Consolmagno, you would assume that Guy, grew up speaking fluent Italian. He grew up in Detroit, okay? Okay, so not at all. But once he moved to Italy, became a Jesuit and wound up there, a lot of the time he learned at least what sounds to me like good Italian. You could fool me. He rather enjoys listening to me try to read from the Italian version of our book, because I have a foolproof technique. I have pretty decent schoolboy French, so I pronounce it as French and I move my hands a lot. Somehow he finds that amusing. I don't know. Well, you can see, okay, this is Castor, and I can kind of piece this together. Well, Cambridge Press doesn't always communicate well with you, so I didn't know there was another language translation, and I was an outside reader at a master's thesis defense in an astronomy department, and this guy comes up to me and asks me if I would sign his book. And I was wondering why he wants me to sign some random book, and I looked down and it looked vaguely familiar. It was the Korean edition, and it is really odd to have something that you wrote that you're utterly incapable of even starting to read. For Fortunately, whenever there's a Messier object, it's still like M45. That's about all I could read. I've currently got a Korean grad student, and he at least helped me. He pointed out to me where my name was. So one of the things that's kind of near and dear to my heart that's in the latest edition of Turn Left is a sort of night-by-night view of the moon. Because the moon is an object that evolves through the month, hence the name. And there are really interesting things to see. There is real geology there. Rills, mountains, in this case, normal faults. It's a great object to look at. It's not just the enemy. To stargazers in general, the moon is the enemy. But it can be something other than the enemy, enough so that I'm actually talking with Cambridge about the possibility of putting together an observational geology of the moon book, along with a very gifted astrophotographer we know. This won't be the title, but my tentative working title on it is Turn Left at Tranquillitatis. This is, yes, stargazers know, particularly those of us in the eastern half, know this image with great sadness. It's the sky brightness at night. And the east is very different than the west, needless to say. A guy may complain about, here in the Detroit area, although as a kid he did get to spend some time up by the lake, but he's got nothing on me. That's where I grew up. Okay, so I was 3 blocks north of the Bronx, right over the city line. So everything of interest, really, as stargazers know, almost everything is towards the south. So I'm looking over the Bronx and Manhattan, under streetlights. So, with my first telescope that I got out of the proceeds of a paper route, delivering the Yonkers Herald-Statesman, what can I really look at on a regular basis? The moon. And it is an endlessly fascinating object. This was during the time of Apollo. So I could really, upcoming mission, before Apollo 15, I knew my way around Hadley Rill really well. I could have told Dave Scott where to go. The first geology book I ever read was Geology of the Moon by this great geologist at Brown, Tim Much. And to me, I would look at an Apollo landing site and the geological maps associated with it, and that's how I got into geology. I learned stratigraphy, the eras, the Preambrian, the Imbrian, the Eratosthenean, the Copernican, long before in college I learned about Cambrian, Ordovician, Silurian, Devonian, and all of that. Tectonics is just the study of what happens during all that time. Or, as I like to define it, the study of things that go bump in the crust. Okay? Okay? Plate tectonics, our ruling paradigm, is very young. For my generation of geologists, it's like being an astronomer right after, having studied under Copernicus, after the Copernican revolution. Plate tectonics is that new. I know most of the main figures, and I've taken classes with, and I've given talks with, and so on, the main people who created plate tectonics. This process of having lithospheric plates, oops, didn't mean that, process of lithospheric plates that move around is controlled by and controls the flow of heat in the Earth. So whatever planet you're looking at, active tectonics comes down to Where does the heat come from? And how is that heat released? That's true in any planet. For the heat engine we call the Earth, it runs on about 40,000 nuclear power plants worth of energy. And it's about equal, as far as we can tell, it's about equally divided. About half of it is actively being generated through the decay of uranium, potassium, and thorium in the Earth. The other half is primordial. Dates back to the accretion of the Earth, the formation of the Earth's core, the big splat, the event that produced the moon, and so on. So when you look at the moon, and to somebody like me who studies mountain belts, I see the Apennines. That's really exciting. But then I realize they're just part of the structure surrounding the impact basin that came to be Mare Imbrium. They're a passive thing. They're there because the moon got hit, not because the moon's having its own tectonics. So lots of early tectonics and volcanism, but that was over quite early in lunar history. And most of what tectonics had was really in response to impacts. So maybe you go to Mercury. It's smaller than the Earth, but it's quite dense. It's got a big core. Well, it turns out it's covered with craters, so it's very little tectonics, except for lots of thrust faults. And this is really telling. I showed you before the straight wall on the moon. That's a normal fault. What that means is this. If you've got a dipping fault, and the top side moves down, look what happens to my elbows. That's extension. If you want to shorten a crust, two ways to do it. One is to fold it, and you see my elbows get closer together with this folding. The other is thrust faulting, where the rock on top goes up. Mercury is full of thrust faults. So this sounds like tectonics. That's the kind of faulting you have at plate boundaries, making mountain belts like the Appalachians and the Himalayas and so on. Sounds exciting, except it's all because the planet cooled and shrunk, so its crust was too big for it. As the crust shrunk, there were thrust faults all over the place, looking like that. So I mentioned before that our former mentor, Sean Solomon, was the chief scientist on the Mercury Messenger mission. So I enjoy giving him a hard time about this because a lot of the tectonics I know I learned from him, and I tell him, Sean, your planet is not real tectonics. Okay. Wrinkled folding rather than thrust folding, but it's just like an old apple. It's just the tectonics is only because it shrunk. Mars, a much better candidate. Look at Valles Marineris, huge Graben system. The volcanoes of Tharsis, incredible. Talk about heat coming out. But Tharsis is there because Mars is a one-plate planet. It doesn't have multiple plates moving around. It just got this one plate that's this big thermal blanket. The heat had to come out somewhere. It found this place, Tharsis, and kept on going for a very long time. So volcanically very nice, but it's not real tectonics, certainly nothing like plate tectonics. Have to admit, it's really impressive. It makes Earth volcanoes look, Olympus Mons in particular makes Earth volcanoes look pretty tiny, but it is not tectonics. There is some faulting, some rather nice. You don't need to have taken my course in structural geology to see in this is an image from space looking down, and you see this dark layer. It's obviously offset by a fault, and a big fault and some smaller faults, and there's a smaller subsidiary fault here. But this is small scale. This is not planetary tectonics. Maybe the best candidate is Venus, our twin sister. Well, given the conditions there, maybe the evil twin sister, but our twin sister. And we know that it's active. Looking in the Guinea-Kikasma area, this is a geological map that was made from radar data, because that's the only way you can see the surface from space. through radar. And this is thermal data from European spacecraft. You see this thermal anomaly? 2 orbits about 2 days later, that thermal anomaly was that much bigger. They caught a volcanic eruption in the act. That's cool, or hot. But it turns out nothing quite like plate tectonics, planetary scale plate tectonics there either. Why not? Well, the best idea is that we have plate tectonics, the ability for plates to move long distances laterally because they're riding on a very weak layer called the asthenosphere. The asthenosphere is weak in part because it's hot there, but also because of H2O in the mineral structure. Don't think of it as, loose water, but H2O in there with the minerals. And when you do the experiments, it turns out a couple of tenths of a percent of H2O makes a huge difference in the strength, makes it much weaker. So that gives us a gliding surface that the plates can move on. Venus, you'd expect, would be hotter, and therefore weaker, but Venus formed just that much closer to the sun, lost more of its volatiles. It's very much depleted in water compared to the Earth. So the lack of that water would make, for a strong asthenosphere, make it much harder for any plates to move laterally. Okay. I think planets are like birds, okay? If you take a big turkey, a small turkey, and a Cornish game hen out of the oven at the same time, the Cornish game hen is going to cool a lot faster, right? If you do this with planets, the same thing happens. The Moon and Mercury just cooled a lot faster than Mars, which cooled a lot faster than the Earth. This is a large part of the explanation for why the Earth is still very active tectonically. Mars was active, and the Moon and Mercury were dead from very early on. And what applies to the Earth applies to its evil twin sister, except that that activity didn't take the form of plate tectonics. So we can understand why some bodies in the solar system are or were tectonically active. It starts out to be a bit of a surprise that so many of these other small objects are. The clue comes in the little experiment of the Jovian system. Turns out if you've got a single moon around a planet, works its way eventually into a circular orbit, and everything is happy. But if you have a second moon whose orbital period is a small integer ratio with that first moon, it can perturb the orbit. So in the case of Io, the orbit is non-circular. Every time it's at perigove, the closest point to Jupiter, it gets distorted into a shape sort of like an American football, literally by about 100 meters. And then in its less than 2-day orbit, then it's undistorted as it gets to apogee and back and forth. Well, if you've taken a paperclip and flexed it back and forth, you know it gets warm. So this explains, this nice little experiment that Jupiter's been kind enough to give us, explains why, even though Ganymede and Callisto are much deader, Io has got this incredible active volcanism. And you can actually look in infrared and see the heat from that volcanism. Volcanically, Io makes the Earth look dead, frankly. There's Enceladus. It's in a resonance with Dione, 2-to-1. And there are these famous plumes that have been sampled, were sampled by Cassini before Cassini recently, very sadly, committed suicide. I assume that's not a problem with the church. But it's, yes, it was murdered. It was, yes. So the chemical composition is actually quite interesting and may suggest that it could be a hospitable place down deep for methane-producing life. And the famous tiger stripes can again be imaged thermally. We know they're producing warm material coming out. And you can add up the energy of that, and people have done this, not me. And here it is in units of nuclear power plants. And it's producing more than is expected. This is probably a cyclical variation kind of thing. But there are other theories. So models for generating the heat in Enceladus, because through this interaction, indicate that if ideally Mimas should have been producing much more heat than its very dead-looking surface. Looks like it's just covered with craters. So here's the question for you. A long, long time ago, in a moon far, far away, what could have allowed Mimas to strike back against such heating? I don't know. There are various theories. The answer probably is a little more mundane than that. But I kind of like the other theory. And finally, looking out even at Pluto. Yes, Charon is a very old surface, tectonically dead, but it had some activity early on in its history. Ancient extension, wearing a little red beanie of organics from Pluto. Pluto is so cold that H2O ice is a really strong rock. The idea of nitrogen as flowing ice, making the surface so young that big parts of the planet don't have any impact craters, is just astonishing. This is not what I expected. Guy and I were actually at something where I was scheduled to give a talk about tectonics in the solar system just before the flyby, and my final few slides were explaining why Pluto was so boring. Oops, I had to change that real quick. So just the idea of floating waterized crustal blocks with this cryovolcanism is just amazing. So let me sum up by saying there's an extraordinary variety of tectonics around the solar system. And the rocky and icy bodies of the solar system have a lot to teach us who are Earth-based geologists about the study of things that go bump in the crust. But I'll tell you this, be it ever so lovely, there's no place like home. Thank you.
Richard, if you can come up and set up your computer here, and I'll entertain a few questions if we have any for Dan. I should point out, when we first met, I was still a postdoc, I wasn't a Jesuit yet, we were comparing our dreams as kids. And he said his dream was to be a Jesuit astronomer. And I knew that the girl I was married would be British. So when I found out he had a British wife, I realized what I had to do.
Right now, my wife is visiting family in Cornwall.
Any questions? Yes, in the back first. Yep.
Does our Earth plate tectonics, does that cause the ocean, Pacific Ocean, El Nino?
No, the question is the plate tectonics linked to El Nino? Not directly, except that plate tectonics governs where our ocean basins are. And as those of us who live near coasts know, that certainly controls weather systems and
why
things like that.
Why do we call it El Nino? It's specifically from the warming Pacific.
Yes, it's from the warming Pacific, but that
why is that getting warmer?
It's really more meteorological. The meteorological system there does not appear to be coupled into, say, the heating from the mid-ocean. Not directly. The numbers don't work out quite right. I've always wondered about it because one of the big factors is that plate tectonic variability over time has affected atmospheric composition and ocean chemistry over some longer time scales than that. So they're definitely compensating.
And one other question. Yeah.
What dictates how many plates you get in plate tectonics?
So what dictates the number of plates you end up with and how big they are and exactly how fast they go? Well, one of the things I was working on as a grad student with John Sullivan was history of rates of plate motion and trying to understand the driving forces and what governs the scale. A great embarrassment.
in our field is, if you get sort of a half dozen people working in the field together, you'll have about 7 opinions.
And I guess one last question.
Quick. Have you noticed, or do you know if there's any type of lunar activity going on? Anything volcanic or any fissures, anything that anybody's done any work on?
Nothing that I really believe in. Growing up, I would always look at Alphonsus because people had talked about seeing transient events there. The only real transient events that I know are truly documented are on the moon, are the ones due to impacts. But boy, as a kid, I would always go to Alphonsus because that's why one of the Ranger missions went there, because people have reported seeing what looked like gaseous emissions.
Yeah, thank you very much.